to learn regarding the searching algorithm. Okay, so we have learned that sorting algorithm till yesterday. So today we need to look at the searching algorithm. Okay, so basically the searching algorithm is the method to find the specific item of the information from the collection of data such as a list, array or database. Okay, so imagine like you are looking for the friend's name, okay, in your phone contact list. Okay, and the way you search depends on whether you list is sorted or not. Okay, so and how you approach the problem. So searching algorithm works similarly. Okay, for example, I will give one scenario for searching for a book in the library. Okay, so the main thing we need to find a specific book called the like title called it something like learning JavaScript. So we need to find one a book. The book name is the learning Java. Okay, so in the we have the two types searching algorithm. One, it's a linear one, and one more, it's a binary. Linear searching and binary. Okay, so here so basically we can say there is a book. Okay, so there is a learning book and some other books also is there. This is a one collection, you can say. This is a one collection. Okay, in this collection we have some books. Okay, the first book, it's a learning Python, and second one, it's the learning JS, and third one, it's a learning Java, and fourth one, learning HTML. So here we need to find the specific element, the specific book. Okay, so for that thing, so we have to use the searching algorithm here. Okay, so there are the two types algorithm. One, it's a linear, and another one more, it's a binary. Okay, so in linear the linear algorithm, in the linear search, the linear search the linear search algorithm basically, like this is simple way to find the element in the list or array. Okay, and basically it start at the beginning and check the every element one by one until the target is found. Okay, so we have some characters for the linear search. Okay, one is the straightforward. Okay, these are the key, we can say the keys. Okay, the first one, it's a sequential and a straightforward. Okay, so next thing we need like works on the both sorted and unsorted array. Works on both sorted and unsorted data. Okay, so why we need this linear search? Okay, so the linear search is very effective in the certain scenario because of it's easy to implement and understand the beginners. Okay, and next thing, it's a does not require the data to be sorted. Okay, and the third thing, we can say it can handle the both small data sets and the data sets with the irregular structure, we can say. So these are the three things of we need a linear search. First one, it's really easy to implement and understand for the beginners. Okay, and next thing, it does not require the data to be sorted. Okay, and third thing, it can handle both small data sets and data sets with irregular structure. Okay, so when to use this one, the linear search? Okay, the linear search is an ideal when the data set is small and the performance is not concerned. Okay, and second thing, the data set is unsorted or dynamically updated, and third thing, you need to simplicity over the speed in the implementation. So these are the three things, like we can like use that linear search. Okay, so way to use, like where the linear search you can use with. First of all, the linear search find the applications in searching through unsorted array. Like for example, you can take regarding that looking for a contact in the unordered list. Okay, and next thing we can see that low power embedded system where the memory or computational resource are limited. Okay, and third thing, you can see the debugging scenario where the simple traversal is needed actually. Okay, so now we need to know regarding how does linear search works. Okay, so the linear search works by iterating through the each element of the array sequentially. Okay, for every element the compare it with the target. Okay, and if it is matched, the return the index. If it is does not match, by the end of the array it return -1. Okay, so the linear search algorithm, I will write the pseudocode for step by step. Okay, the first thing, we need to start at the first element. Start at the first element. First element in the sense index 0. Okay, and second thing, we need to compare the element, compare the current element with the target. Okay, and third thing, if they are equal in the sense the current element and the target, the both are equal, we need to stop and return the index. We need to stop and return the index. Okay, the fourth thing, if not move to the next element, move to the next element. Okay, the fifth thing, we need to repeat until either the target is found. Okay, so these are the five steps we need to follow for this searching algorithm. Okay, for that thing we can write the code for a linear search. Okay, so we'll go for the code editor. Online IDE. Okay, so here we have the main method. Okay, so here we need to create one separate method called linear search, public static and int, because I need to return something. For that thing I am giving the int. Okay, here my method name is the linear search. Okay, we need to pass the array. Okay, and we need to pass that int target. Okay, so here we need to define that like the int array and target. Okay, so int array is 12, 32, 45, 67 and 88. Okay, so our targeted element is the target element is 45. Okay, so we need to return the index. Okay, so here we need to iterate through the array. Okay, we need to apply the for loop here. For int I is equal to start from the 0, okay, and I is less than array dot length, okay, and the I plus plus. Okay, so here we need to check if the current element matches the target. Okay, if that current element array of I in the sense is the current element is equal to target, then we need to return the like index. Okay, suppose if it is like is not equal to, in the sense, suppose that like if it is not, target is not found in the array. Okay, so we need to return the -1. Okay, so this is our scenario for the linear search. Okay, so we can call that method here int 1 minute. Okay, inside this thing I will create that linear search. I will pass that array and target. Okay, so I will check linear, what is the, cannot find, yeah, spelling is not correct, LARCH. Okay, so now our index is 2, like index is 2. What is our index 2? The index 2, index 0 is the 12, index 1 is the 32, index 2 it's the 45. Okay, so now here it's showing that targeted element is available in the index 2. Okay, this is for the searching algorithm. Okay, so we will do for a dry run for the searching algorithm. Okay, so here we can take this one and okay, this is our loop. Okay, so we have the two things. One, it's array. The array contains 12, 32, 45, 67, 88. Okay, this is our array and this is our target element. Target element is at 45. Okay, so we can see the first 12, it's a 0 index, 32 it's a 1 index, 45 it's a second index, 67 is the third index, 88 is the fourth index. Okay, so here in the first step, okay, so here we need to compare that first element, the first element 12 with the 45, okay, the 45. Okay, so here does not, like it's not matched. Okay, so we need to move to the next index. Okay, for this second step. Okay, second step we need to check, okay, is that 32 with equal to 45? No, we need to move to the next step. Okay, here we need to check that 45 is equal to with equal to 45. Yes, here we need to return this third, like this index, third index, you can say here is the 2. Okay, so our output will be the 2. Okay, so this is regarding the search, linear search. Okay, so next thing we can see regarding that binary search. Binary okay, so binary search, basically the binary search is an efficient algorithm used to find the position of an element is the sorted array. Okay, basically it repeatedly divides the array into the two halves. Okay, so we can see basic like we can see how that binary search works. Before that, we need to check why we need this binary search. Okay, so why we need, in the sense, it's a much faster than linear search for the large data set. Okay, and the next thing we can say, it's utilize the sorted property of an of the array for the efficiency. These are the two things we need that binary search. First one is a much faster than search linear search for the large data set. Okay, and second thing, it utilize the sorted property of the array for efficiency. Okay, and when to use this binary search. Okay, the thing is, suppose the data set must be is sorted. Okay, for the binary search, the data set must be sorted, then only we can use the binary search. Okay, and next thing, when the searching large data set with the predictable structure. Okay, and third thing we can say, when the performance and speed are critical, so then we can use the binary search. Okay, first thing, the data set, the array must be the sorted. Next thing, when the searching large data set with the predictable structure. And third thing, the performance and speed. Okay, so where to use this binary search. Okay, the searching through the database or log files. Okay, and second thing is the searching for an element in the sorted dictionary or maps. Okay, and third thing, finding the elements in the sorted sequence, such as in competitive programming, we can say. These are the three things we can say regarding the way to use that binary search. Okay, so now we need to know like how does a binary search works. Okay, the basically the binary search start by the dividing into the array into the two halves. Okay, so we'll write the steps for the binary search, so how it works basically. So first thing, we need to find the mid element. We need to find the middle element. Okay, and second thing, so we need to compare with it with the target. To compare it with the target. Okay, so if the equal, if equal, we need to return the index. Okay, if the less, we need to narrow that search to the right half. Narrow the search to the right half. If greater, then narrow the search to the left side, left half. Okay, so we need to repeat the until the target is found. Okay, the range becomes empty. Repeat until the target is found. Okay, so we can do code for binary search. Okay, the first thing, we need to initialize the array. Okay, so our array is the same thing, 12, 32, 45, 67, 88. Okay, so our targeted element is the int target is 45. Okay, so here we need to create a separate method for the binary search. Okay, public static int, I need to return something. For that thing I'm using the int. Okay, binary search is our method name. Okay, we need to pass those array and target here. Array and int target. Okay, so here we need to define the search boundaries. Okay, the search boundary in the sense int low in the sense start from the 0. Okay, high in the sense it's a last index. Okay, the high means it's a last index. The array dot length -1. So this is the search boundaries, we can say. The low is the 0, means the 0 index. The high is the last index, we can say. Okay, so here we need to apply the while loop. The low is less than equal to the high. Okay, so here we need to find the mid, because of we need to divide the two sub array. Okay, int the mid equal to the low plus the high minus low 2. Okay, so here why we need this mid means we need to avoid the overflow for that thing, so we are using the mid. Okay, and so here we need to try, like we need to add the condition for defining the target. Okay, so the condition is if the array of mid is equal to target, then we need to return the mid. Okay, suppose if that array of mid is less than target, if the array of mid less than target, so then a search we need to search in the right half. Okay, the low mid plus. Okay, suppose that array of mid is less than target, we need to search in the right half. Okay, skip the left part. Okay, if the array of mid is greater than target, so then we need to make that search in the left half. Okay, that high is the mid -1. The mid -1 in the sense we need to check the search in the left side array. Okay, suppose the target not found, so we need to return the -1. Return the -1. Okay, so now we need to call that method in the main method. Here the binary search. Binary search, we need to pass the array and target. We need to check what is the error. The error is high. Something went wrong. The high. Okay, so we need to add the like comma instead of colon. Yeah, so this is our output. Okay, so here our array is the 12, 32, 45 and 67 and 88. Okay, our targeted element is the 45, so the 45 is it in the second index. Okay, so our output also is the second index. Okay, so now we can dry run for this thing. We'll copy that code. So our array is basically, okay, our array is 12, 32 and 45 and 67 and 88. This is our array and our targeted element is 45. Okay, so here the index start from the 0. 12 is a 0 and 32 is a 1 and 45 is a 2 and 67 is a 3 and 88 is a 4. Okay, the first step, okay, the first step, okay, here the low is the low is equal to 0 and the high is equal to 4. The high is equal to 4. 4 in the sense it's a max length, like the last element. Okay, 0 1 2 3 4. The high is the 4, low is the 0. Okay, so we need to find the mid. Okay, the mid we need to find low plus low is the 0. You can see here this formula, low is the 0 plus low is the 0, the high minus low. Okay, the high minus low, high how much? It's a 4. Okay, 4 minus 0, okay, then by 2. Okay, so now our mid is equal to 2. Okay, so we need to compare that array of 2 with the targeted element is the 45. Okay, if that array of 2, we need to check in the array, in this array. What is the array of 2 in the array? It's a 45. Is a 45. Okay, so then if it is the 45, so here in this condition, like we have got that output, that array of mid is 2 and the targeted element is 45, and we need to return that mid. What is our mid? 2. Okay, 2 is our output. So this is regarding the binary search algorithm. Okay, so are you guys understand this code?
Yes, sir.
Binary search and linear search.
Yes, sir.
Yes, sir.
Okay, can you tell me about like linear search, like how it works? You can see the code and just, can anyone try to?
Yes, sir.
Okay, try to explain the code actually, how it works.
First, we have to start with the first element, and next compare the current element with the targeted element. And if they are equal, we have to stop and return the index. And not equal, we have to move to the next element. And to repeat until either target is reached.
Okay, and what about this one?
First, compare the
Your voice is breaking.
because now, sir,
Now it's audible. Yeah.
our targeted element is 45. So we have to check with first in 0th index like 12 with 45. 12 is equal to 45. Then next 32 with 45, but 32 is not equal to 45. And go to the next iteration, third one, that is 45, index 2. So 45 with 45, it is equal to 45. So the output will be 2. So the index number 2. It is the output.
Okay, so right now we are returning the index. Okay, suppose if you want to return the number, like the element, so we need I need this 45 instead of 2. So what should I do here for all? Kaustubh, Yuvraj and Priyanka. Instead
So
of,
repeat. You-
sorry, again,
So
ignore this one. I will open that linear search. Here show me, like, we need in a index instead of that number, like the element 45. So what should you do for this thing?
the targeted element is 45.
Yeah, the targeted element is in 45 only. Okay, so here we are returning that, like, output is 2. Like index we are returning, just I'm like simple asking, like, so instead of index, so can we return the element?
Yes, sir.
How? What about Yuvraj and Kaustubh? So we'll give one problem here. Okay, the problem is searching the book in the library. Okay, searching for a book in a library. Okay, so there is a books called, the one, it's a book name, it's a DSA, and next book name, it's a Python. Okay, and next book, it's a DBMS. Okay, and the next book, it's a Java. Okay, so here we need to find search the Java. So can anyone give me the approach, how can we do this problem using the linear search? Can anyone try to
compare the Java with other 3 books,
So what about code
like
thing?
DSA with the Java, Python.
Okay, what about a code thing here? So what should I give the variable? Library is our variable name. Okay, so what should I give the data types?
Remove the int.
So what should I give, either int or string?
Strings, sir.
Okay, so this is our string. Okay, so now we need to add the targeted element. Okay, the targeted element is target book equal to Java. Okay, so what should I give the data type for targeted book?
String.
Okay, so now you can tell me the code wise. Okay, here we have given that for int is start from the I equal to 0 and I is less than array dot length, okay, and I plus plus. And what should I give in the condition? Kaustuv Yuvraj. So right now we are using the string. Okay, for the string we have some keywords, reserved keywords. Okay, instead of that equal. Can anyone try? Am I audible?
Yes, sir.
Okay, so can you try? Just I need one condition, that if else, if part only. Just we need to change in the line number 5. What should I change here? Priyanka, Kaustubh and Yuvraj. Just try. If it is wrong, not a problem actually. What about Priyanka? There is only one line actually. I need to change. Am I audible?
Yes, sir.
Okay, can you tell me the line number 5? What should I add? Leave it. We will do here. Okay, so here we need to call the linear search method. Okay, in that thing we have to pass that array. Instead of array we have to pass that library. Okay, instead of target we have to add that target book. Okay, and here so in string so we have some reserved keywords. Okay, instead of double equal to we have to add that equals. Okay, the equals the target book, then the in the return the return the index. Okay, we will check why. In the sense we need to pass that target book in here. Okay, we will check once. Now we need to pass that instead of array we need to pass the library. Okay, instead of the array we need to add that library. Why it's giving the error? So we have, okay, we need to change the data types here. Instead of int, so I will add a string. Okay, here also we need to add a string. Okay, So now you can see our output is the 3. Okay, so the DSA it's a 0th index, Python is the first index, and DBMS is the second index, Java is our third index. So our output will be the third index only. Okay, am I audible? Got it?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so now one more problem is there. Okay, so regarding the same thing, but we'll check once. Okay, leave it. We'll start the exception handling. Okay. Exception handling. So basically, the exception handling is the Java. Basically, in the Java, we can say it's a mechanism. Exception handling. Okay, because of it had to handle the runtime errors. Okay, and basically we can say it ensured that the program runs smoothly by catching the unexpected errors, providing the meaningful messages, and preventing the crashes. So this is for using that exception handling. Okay, the thing is why we need the exception handling actually. Okay, the first thing why we need the exception handling. Okay, the first thing prevent the crashes, prevents the crashes. Okay, here it avoids the terminations of the program. Okay, and next thing here we need to add one more thing, it's improve the debugging here helps to identify the root cause of error quickly. Okay, and third thing for the enhances the user experience. Here like we can handle the errors with a user friendly message. Okay, and fourth thing it's a separate concern. Okay, the concern in the sense like you can keep the main logic clean by separating the error handle code like that. Okay, so now we need to know a thing like we need to know regarding that where and when is the exception handling is used. Okay, so the thing is wait, so you can see in the real time application there is a banking application. Okay, to handle the insufficient fund and or transaction errors, so there we can use the exception handling actually. Okay, in the banking application. Okay, and second thing for the file operation to manage the file not found or permission issues. Okay, in file operation operations. Okay, and next thing you can say the web applications. Web applications here we need to handle the invalid user input or server errors or broken connections. Okay, so when to use this one actually, so we have see like way to use. Okay, so now we need to check like when to use basically. So the thing is whenever there is a potential for runtime errors, so then we can use the like the exception handling, like whenever there is a potential for runtime error such that such as that dividing by 0. Okay, and accessing the invalid array indexes. Okay, and third thing is the null point exceptions. null point exceptions when accessing the object, when the accessing object. Okay, fourth thing is the network related errors. Network related the errors like timeout. Okay, so now we need to learn like how does the exception handling works. Okay, the exception handling using that try, catch and finally block to catch the errors and manage the cleanup. Okay, so here we can see it's an advanced mechanism including that creating the custom exceptions and using the throw to the propagate the exceptions. Okay, for example, I will add for the like I will give the try method like for the try block. So basically here we need to know these are the try and catch and finally. Okay, so we need to use for the except handling, and one more keyword is there is a throws. Okay, so now we need to code for the try block. Okay, the block of code might throw exceptions like for a scenario like you are reading the file. Okay, and it might not exist. Okay, we need like the wrap the reading code in the try block. Okay, for example I will write here only. The try block basically you are reading a file and it might not exist and wrap the reading code in the try block. Okay, there's a try block. Okay, so here I will create one instance for the file reader. Okay, the file equal to new file reader. Okay, the file reader instance we can add any file. Okay, so here and yeah, this is our try. Okay, so here we need to throw the error also. Okay, for the catch block. Okay, the catch block basically handle the specific exceptions if they occurs. Okay, so I will add the catch block also here. Okay, so the catch block. Okay, the catch block will add the file not found exceptions like that. File not found exceptions dot e, and here we need to print that system dot out dot println file not found. File not found. Okay, so we can write the try catch block like this. Okay, the try in the sense the block the code that might throw exceptions. Okay, the catch block here it's a handle the specific exceptions if they occur. Okay, and third thing we need to use that finally block. Okay, for that thing so we can use the like one more problem for that thing. We need to execute the cleanup code regardless of whether an exception occurred. Okay, for a scenario we will take the closing the file after reading whether or not an exception is thrown. Okay, the first thing is the try. Here I will add the buffer reader. Okay, here I'm just add like creating that instance that reader. Okay, reader. Okay, here we'll create a new buffer reader, and I'll create a new file reader here. The new file reader, that's the data.txt. Okay, so here I will print that system.out.println reader.arrayLine readline. Okay, so in the catch block we need to add, in the catch block we need to add that IO exceptions .e. Okay, here we need to print that file operation failed. The file operation failed. File operation failed. Okay, so here we need to add that finally. Finally, we need to print that the file operation completed. We'll throw the error like this. File the operation completed. So this is regarding the try, catch, and finally method. Okay, the fourth one is there regarding that throw and throws. Okay, the throw and throws in the sense I will create here throw and the throws. Okay, the throw means basically the like explicitly like throw an exception, and throws means declare the exception a method might throw. Okay, we'll code for this thing. Okay, so here I will do one thing here. So here I'm trying to create age is less than 18. Age is less than 18. So then I will throw that error. Throw, I will use those error like keywords here. Throw a new exception. The age must be 18 or above. Okay, I will check this. So before that thing, okay, we'll check this one. Okay, before that thing we need to create a method instead of directly adding green the static void to validate age. Okay, we'll do this one here. Okay, static void validate age. Okay, here we need to put that age. Okay, and here we need to close that exception. The exceptions. So here we need to add that one. Okay, so this is for the throw is the explicitly throw an exception, and throws means declare the exceptions a method might throw. Okay, for real time example, the banking application in the sense like I will do code for the banking application. Okay, so the user try to withdraw the more money than their balance. Okay, so now we need to throw the error on that time. Okay, user try to withdraw the balance, int balance is 5000. Okay, so here the int withdrawal is the 6000. Okay, so then here we need to add the condition that withdrawal is greater than balance. Okay, we need to throw that error, throw the new exception. Okay, it's insufficient fund. Insufficient fund. Okay, so here we need to throw that print that one. It's a withdraw successfully, otherwise with success. Okay, in the catch method we need to add that exception the e. Okay, here that system dot get message. We need to run this code. Public static. Okay, yeah, here you can see we are throwing error using the throw new exception method. Okay, here you can see that insufficient fund. Okay, so this is regarding that exception handling. So we will do more problems on tomorrow regarding the exception handling. So are you guys understand the exception handling?
Yes, sir.
Yes, sir.
Okay, then not a problem. Okay, then we'll wrap up the session. Okay.
Okay. Yeah.